the word sine actually comes from a Greek word that means half of a chord. The problem is it was translated from Greek over into Arabic, and then from Arabic it was translated into Latin. And when they translated it into Latin, they mistranslated it. They translated it as sinus. What do you think of when you think of sinus? Yeah, so the word sine, it actually does refer to your nose. It's supposed to refer to a half chord. But those are the mistakes that happen sometimes. The way that we actually spell it is this. Sine of theta, okay? So S-I-N-E. So when you see S-I-N, please don't say sin. Okay, we talk about that in church. And I suppose we may be sinful at math from time to time, right? Okay, sometimes. But please don't say sin, please say sine. And here's how we compute sine. If you have an XY coordinate and a radius, the way we compute sine is we take the Y value of the terminal point. So we just talked about finding terminal points, right? You take Y and you divide it by R. You tell me, what is the radius in the unit circle? 1. So if R is 1, this ends up being just Y. We don't say cos, we don't say cos, we don't say cos, we say cosine. This means cosine. Cosine of theta is x divided by r. And if r is 1 in the unit circle, then what is this equal to? We don't say tan. That's what happens when you go to the Caribbean. Okay, we say tangent. This is the tangent of theta. And it means you take y and divide it by x. Those are your 3 most common trigonometric functions. Here's 3 others. I still have students that when they see this, they say kasuk. Don't do that. Let's act like we belong in the course, okay? Cosecant. Cosecant. Cosecant is the reciprocal of sine. So it's r over y. Or in the unit circle, 1 over y. Or 1 over the sine of theta. Cosecant, the reciprocal of sine. Anybody want to guess what this one is? Secant. Thank you for taking a shot at it. Yeah, that's a good point. Secant is the reciprocal of cosine. It's r over x, which in the unit circle would be 1 over x. Or 1 over cosine, reciprocal of cosine. You want to guess the last one? Cotangent. And cotangent is going to be x over y, or 1 over the tangent of theta. When you see sine, cosine, and tangent, you probably think to yourself, SOHCAHTOA, right? We'll get to that. That takes all of 1 day of trigonometry for us. Trigonometry is much bigger than that. So let's see what we're supposed to do today. Good thing is that this lesson is easy for you guys because you already know what you're doing. So flip it over. We are going to determine the exact value of sine of pi over 3. How are we going to do that? We're going to draw ourselves a little picture. Next page. Pi over 3 is how many degrees? 60 degrees. So I draw a 60-degree angle. I need to determine that coordinate. Let's solve the triangle. The hypotenuse is 1. What's going to be this side? Half. How about this side? Root of 3 over 2. So what's the coordinate? 1/2 root of 3 over 2. So if you want to determine the sine of pi over 3, you simply choose the y value. And what is the y value? So if you understand how to do the terminal points, today's lesson is not too challenging, is it? Now, let me make a point with you. If I turn on my calculator, and I turn it on, and I go into my mode, notice I have radians and degrees. I'm going to type in sine of, and I'll choose pi divided by 3, and look at what I get. Okay? That's a pretty tough value to come up with. Okay, how does your calculator know that? There's a lot of actually calculus that goes behind how your calculator is able to figure that out. Look what we got. We got the square root of 3 divided by 2. Whoop. Sorry. There we go. Exact same value, right? If on the test, you're asked to find the sine of pi over 3, and you just plug in your calculator, write that down, for that I give you 0 points. Okay? You must do the geometry. Cosine of 4 pi over 3. 4 pi over 3, how many degrees? Somebody. I'm switching it to 4 pi over 3. Close, not 210? Nope. 240. Which quadrant? Third quadrant. What's my reference angle? How far past 180 have I gone? 60 degrees. Let's solve this triangle. We know that the hypotenuse is 1. What are the other two sides? 1/2 and root of 3 over 2, right? So what's my coordinate? So I'm looking for the cosine value. What's the cosine value? X. So the cosine of 4 pi over 3 is negative 1/2. Last one, then we go to our worksheet. Tangent is 7 pi over 4. Anybody, 7 pi over 4? (315 degrees). What kind of special triangle do I have? 45, 45, 90. So what are the sides going to be? Root of 2 over 2 and root of 2 over 2. So what's my coordinate? Good. How do I compute tangent? Y divided by x. So if you take your y value, you have negative root of 2 over 2, and you divide it by positive root of 2 over 2. What happens if you take a number and divide it by itself? You get 1. If 1 is negative, then it's going to be take out your worksheet. Well, you can use a calculator. You just can't only do the calculator. I'll help you guys out. I realized after third hour I hadn't communicated as well as I had hoped. So let's go through and make sure that we've got our stuff ready to go. Okay, let's start through your homework and make sure you know what you're supposed to work on. Everybody good here that this is one that you can do? Yes? Which includes the second page as well, okay? We all good? All right, we move along. This one, we did the reference angles, didn't we? And then we also did the second page, which was the coterminal angles. Okay, this one I didn't title it correctly. This is going to be arc length and sector length. Okay, we'll get to that later, but this one is not yet. Okay, not yet. And same with the back side. We are not yet ready for this. As you move past that terminal point, did we do this yesterday? Yep. So you're ready to do that. That's the second side. I know it looks like a lot, but there's only 6 problems per page, so they just take up a lot of space. You should be able to do the entire unit circle, and it looks like people didn't realize that they could do this. Yes, without a doubt, this I just don't have the drawings for. You want to be able to do this as well. Yep. So let's move to what you are going to do today. And that is this. Identify the terminal point as well as the exact value of sine, cosine, and theta. So I'm going to get you started on this piece that you can start working on today. And we're going to start with an easy example. We're going to start with pi over 2. Okay? Pi over 2 is how many degrees? 90. So what's the terminal point? 0, 1. That's easy, isn't it? So what's the sine value? What's the cosine value? And how do I determine tangent? What is 1 divided by 0? Undefined. If 0 is in the denominator, it's undefined. Now, let me help you make a connection. This is part of what makes trigonometry awesome. If you think of y over x, what does that make you think of? Y over rise over run, which makes you think of slope. Slope. Tangent is the same thing as slope, because think about it. 90 degrees, that's straight up and down, right? What's the slope of a vertical line? Undefined. Suppose that it was 180 degrees like this. What's the slope of a horizontal line? And you'd get 0. Tangent is slope. Flip it over. I want to try number 7, 5 pi over 6. 5 pi over 6 is how many degrees? 150 degrees. Which quadrant? Second quadrant. What's the reference angle? 30 degrees. Let's solve the triangle. What's the short side? What's the longer side? So I know that the terminal point is negative root of 3 over 2 and positive 1/2. Once you identify the terminal point, you can figure out sine, cosine, and tangent. What is sine? What's cosine? How do I determine tangent? Divide. This is where some people got lost. I take the y value and I divide by the x value. Uh-oh, I don't like to divide fractions. Multiply by? So I multiply by 2 over negative root of 3. The 2's cancel. What is negative 1 over the root of 3? Can I leave the root of 3 in the denominator? Negative root of 3 over 3. So you are ready to finish that, and then if you flip it over, You're also ready to do this. This just doesn't have the circles. You can complete that chart. You'll see it. And I will take some questions on this piece tomorrow as well. Okay, because some of you will get confused as you go through that. We'll do a couple problems at the beginning of class. The rest of the time is yours to work. Start to get busy. Use your time wisely.